Today, we're going to set up Grafana and Prometheus to monitor our entire Kubernetes cluster the easiest and surefire way out there. The holy grail of every Kubernetes cluster is getting beautiful and meaningful charts filled with glorious data in Grafana. Grafana is a single pane of glass to visualize your data wherever it lives, whether that be on some servers in your home lab, some Raspberry Pis in a cluster, or even a Kubernetes cluster in the cloud. It's able to do all of this without ingesting data from some back-end store or locked away in some database. It uses Prometheus, which is an open source monitoring and alerting system, to create and store time series data. This data is scraped from metrics endpoints using the poll model over HTTP, which makes it really easy to get that data. And then it stores them on the Prometheus server. From there, you can visualize it with Grafana and even set up alerts using Alert Manager. And that's where the challenges start. It's been kind of rough setting up Prometheus properly in Kubernetes with Grafana. There are so many ways to do it, and not to mention how challenging it is to set up Grafana with charts that work, look good, and help you visualize meaningful data. Well, over the last week, I've set out to solve just that. I wanted to create a repeatable way to install and configure Grafana and Prometheus and gather logs from all of my nodes and workloads. And that's when I found the open source project kube-prometheus-stack. This Helm chart installs a collection of Kubernetes manifests, Grafana dashboards, and Prometheus rules, as well as Alert Manager rules to completely monitor your Kubernetes cluster. And there's no guesswork involved. I've already created a configuration that should work on your cluster that will give you the same data as I'm able to collect. But before we get started, I just wanted to give a huge thank you to our sponsor, Datree, for making today's video possible. How many times have you applied a Kubernetes configuration only to realize later that it was misconfigured, not configured according to best practices, or just plain wrong? These types of misconfigurations can create engineering churn and possibly even downtime. That's where Datree can help. Datree is an open source tool that prevents Kubernetes misconfigurations from ever reaching your Kubernetes cluster. It does this by scanning objects against a centrally managed policy. This policy comes with Kubernetes best practices built in, but it's flexible enough so that teams can customize this policy according to your organization's needs. And Datree isn't just a simple YAML enter. Along with YAML validation, it does schema validation as well as checking against your configured policy. Datree also comes with a fancy dashboard that is backed by great documentation to help you fix errors fast. It installs in seconds and can be run from a CLI, from kube control, in your CI and CD pipeline, and even as a Kubernetes admission hook that can intercept and test Kubernetes manifests even in this last mile. To sum it all up, Datree can help prevent Kubernetes misconfigurations from happening in the first place. So help empower your engineers by installing Datree today. Be sure to see the link in the description to get started with Datree today. To monitor our Kubernetes cluster, we're going to need a few things. First of all, we're going to need a Kubernetes cluster up and running. Now, if you need help setting one up, I've created an Ansible playbook that does this automatically for you using Ansible in K3s. You'll want to run a command like kube-control get nodes to make sure that you can communicate with your cluster. This should return all the nodes in your cluster. Now, I'm doing this on a clean Kubernetes cluster when I just spun up with Ansible, but you can do this on an existing cluster and it'll work just fine. But if you are going to install this with K3s and possibly with my Ansible playbook, there are some additional flags you'll need to pass through to K3s. And these additional arguments are listed right here. Now, I'll have these in the documentation and you can find that in the description below. But Prometheus will still work if you don't have these arguments. You'll just have less metrics, which means less charts. So you want to add all of these arguments to get the most data inside of your charts. Now with K3s, you can rerun and bootstrap this again using these arguments, or you can update a YAML file and then restart your nodes. I'll have that in the documentation too. And if you have no idea what I'm talking about, totally fine. You can take care of this later. You just won't have some data in some of the charts. But once you enable these flags, you will. So if you're getting hung up on this, don't worry too much about it. And if you need help from a UI, that's totally fine. I totally get it. A lot of things are easier to visualize with a UI than it is in a terminal. I'll be providing the CLI way to do it, but I'll also be doing some stuff in Lens. Lens is a desktop app that makes it easy to visualize your cluster. And I showed this off in another video, but I'll be using it in this one too. But it makes checking things out, port forwarding, logs, etc. a lot easier than doing it in the CLI. But as I mentioned, I'll be doing both. The next tool we'll need, and this will be the last one, is Helm. So Helm is a package manager for Kubernetes. It helps you install applications by setting some default values from the package maintainers. And it also helps you version those applications too. So you'll want to be sure that you have Helm installed and that you can run a Helm version. This should return something. Just make sure you have the latest version. Once all of that's done, let's install kube-prometheus-stack. The first command we're going to run is helm repo add, and we're going to add this repository to our local machine so we can install this on our Kubernetes cluster. Then we'll want to run helm repo update, which updates our local repository with the latest version. As you can see, I use Helm a lot. You'll see a lot of different repositories, but we can see right here, Prometheus community chart repository. So it's added to our local machine. Next, we're going to create a namespace for all of our components that are included with this chart. Now, this isn't necessary, and if you don't specify a namespace later on, it will just install them to the default namespace in Kubernetes. Now, namespaces are kind of a big topic, but some people use them to organize things or segment things, or even for security. Here, I'm just creating a namespace called monitoring, strictly for organizational purposes. Anything in my cluster that has anything to do with monitoring, I'm gonna put in this namespace. So let's create that. So we created that namespace, and we could test this by running kube-control get namespaces, and we can see our monitoring namespace down there. So next, what we would typically do is run a helm install command, and we would pass a bunch of flags. However, rather than passing a bunch of flags to it, we're going to provide a values YAML file. So this YAML file is kind of like an answer file. If you've ever done anything programmatically before or scripted installation of software, most of those installation packages you can provide an answers file. So think of a Helm values file like an answers file, except for it comes with some default values already. And boy, does it come with some values. This values file is really long. Like, it is super duper long. Like, I'm scrolling and it's thousands maybe lines of YAML. Still going, page down, still going. It's a lot of YAML. So this file is over 3,000 lines long of YAML. Now remember I mentioned that the answers file can provide default values for you? Well, these are the default values. So really, we don't have to set any of these if we want the default values. But we're gonna override a couple of things. And this is where I spent most of my time over the last week, was configuring my own values file so that it runs the way I want it. And here is the values file. I have a lot of values in here, as you can see. And I've trimmed it down to 181 lines. 181 lines. Still a lot of YAML. And I will admit that I do have some default values still defined in here. Now doing that is totally up to you, but I typically do it for knobs and dials that I want to turn later on. It's one thing to know that they exist, and it's another thing to actually change them. This helps me solve both of those problems. So let's talk about some of these. Some of these may or may not be obvious, but we should talk before we just apply this YAML file. So full name override is just saying that we're gonna call this deployment Prometheus. If you don't change this, you're gonna get Prometheus-Prometheus-Grafana- something else, and it's kind of confusing. So I override some of the names of these deployments so they're easier to find, and they look better in my Kubernetes deployment. But I will have to remember in the future that they come from this Prometheus chart, which is actually a Prometheus operator. So we didn't really talk about operators, but you can think of operators like orchestrators of other packages within Kubernetes. So this operator will create and orchestrate all of these packages within Kubernetes. So for this operator, it's operating and orchestrating Grafana, Prometheus, Alert Manager, and more if you wanted to. And you can see some of those rules and settings that we have here. So these are all default values. This was really just for me to know that they exist in case something went wrong when I was configuring it, but I figured I'd leave them here. Next, we're saying for Alert Manager, we're gonna do a full name override and call it Alert Manager. That's so we don't have really weird long names. We're gonna enable it, and I'm disabling the ingress. Now, you might be asking, why are you disabling the ingress? Don't we wanna enable it? Yes. Yes, you do at some point. But because people use different ingresses, I didn't want to enable this. So if you use an Nginx ingress controller or traffic ingress, you can enable this, give it a few labels, and it will create the ingress for you so you can get to these services. Now, I don't enable it because I use an ingress route with traffic, and I'm going to take care of that later with some manifest on my own. So you won't see me enable any of these ingresses. And if you're using traffic and you're actually using an ingress route as well, I'll include that in my documentation. Now, I said ingress a lot. If you don't know what an ingress is, really simply put, it's just a route or a path to get into your service. And if you don't understand that, really, it's just a way to expose this service over HTTP so you can get to it, either via IP or DNS entry. Let's continue. Now that we got the hard stuff out of the way, now I can gloss over the next ones. So next we're saying Grafana is enabled. We're doing the full name override again. And then I have some additional properties, and most of these are default. And then we get to this right here, admin. So these are the credentials, or how we're going to log into the system. Now, if you don't set this, it has a default value, and you can change that later when you sign in. But I'd rather create a secret up front, store that secret in Kubernetes, and then use that secret for Grafana so it has my secure password the instant I deploy it. But just know that we are going to use an existing secret. That secret name is Grafana-admin-credentials. The user key on this secret is the admin user, and the password key on the secret is admin password. So this is really just mapping these values to secrets that plug in. It's not the best diagram, but kind of how it works. We'll create a secret here in a little bit. And then we're turning on monitoring for a bunch of stuff, and this took me a lot of time to figure out. On Kube Control Manager, you'll see that I have it enabled and endpoints. And these endpoints are IPs of my K3S servers, not my agents, my servers, formerly known as masters. And you'll see I did this for quite a few things. So for kube-etcd, we want to monitor that. I gave it the IP address of the endpoints. I also gave it some ports, which the default are fine, but I still specified them so I know what ports they are, and if the defaults ever change, I don't have to worry about it changing. Kube Scheduler, same thing. We're going to monitor it, and we're going to give it the IP address of our K3S servers. And the same thing with Kube Proxy. We're going to do the same thing, IPs of our servers. So that's basically telling it, hey, for all of these services, Kube Proxy, Kube Scheduler, etcd, here are the IP addresses of those services to go and scrape, so we can have those charts later on. So there are a few places where I decided to provide my own keys or values to replace the values that the Helm chart is using. And what I'm doing here, although it looks confusing, all I'm doing is replacing the IP address for these devices we talked about earlier, those servers, with the node name in the charts. So it just looks a little bit nicer, and we'll see that. And for Prometheus Node Exporter, almost the same thing. You will see these extra args specified here, but really, these are the default ones, but I specified them so I could kind of play with their values and so that I know what they are. But I haven't changed anything. If you really want to delete extra args, you totally could, because the default ones are just this. Next, some more relabelings. And for the Prometheus operator, some more resources that I set. And then some additional flags here. Again, most of these are default. So one thing you are not seeing here is storage. So I have a default storage class set up on here. It's going to use the default storage class with the default values and the default retention policies, except for this one right here. I set it to 6 hours. But if you don't have a storage class set, or you have the weird problem where you have multiple default storage classes, you'll want to specify either a default in your cluster so that it just works, or you can set storage keys on these services that need storage and specify which storage class to use. For example, you'll see in the default values, they'll have a storage spec set with an empty object or a struct, depending on what language we're talking about. But you can see that this is empty. The default version is empty. And so if you wanted to supply a persistent volume claim, you can set a claim template, set the storage class, the access mode, how much you want to provision, and then selectors if you need. Now, I recommend doing this in the future rather than take the default values, which for some of them are none. That means unless you're using local node storage, after that container restarts, you're going to lose your metrics. So I highly recommend setting this up. And I'll have some examples in the documentation as well. The only reason why I didn't set it is because I don't know which storage class you're using. Are you using Rook-Ceph? Are you using Longhorn? Are you using local storage? Are you using NFS? All are great, all work. but I'm not sure which one you're going to use. So not super important the first time you launch it, but you'll want to get these in place shortly after. As I said, I'll have some examples, but it's really going to be up to you to determine your storage class, your template, and how much you're going to provision. And it's easy to update these values, as you'll see here in a little bit, and roll this out with new settings. So that was a lot of talk about settings, but I figured it was worth a few minutes to talk about them because they're super important. And a lot of this context you can't get from looking at a values YAML file, especially a default one of over 3,000 characters. So let's deploy and check out our charts. So I did mention that Grafana needs a username and password so that you can sign in, and that we're going to use a secret for it. So let's create a secret really quick so that when we spin up our Grafana dashboard, we can sign in securely using that secret. Now there are lots of ways to create secrets. You could do them in YAML, but then you don't want to commit them, so you would probably encrypt them if you were going to. Or you could do them all from the terminal, but then that's in your history. Or you can do what I'm going to do and echo them out to the file system, but you'll need to make sure you delete them from the file system afterwards. Anyways, this is how we're going to do it. We're going to echo out to a file called admin-user, the name admin user. Next, we're going to echo out to the file admin-password, our super secret password. Don't use this one, but I am. Then if we cat out this admin-user, we should see our admin user there. And if we cat out admin-password, we should see our password there. So we're in a good state. So we're going to create this secret using kube-control create secret generic Grafana-admin credentials. That's the name of our secret. We're going to say it's from the file that we just created, admin-user, and then from the file admin-password. And then we're going to store that in our namespace monitoring. The namespace is really important. It needs to be in the same namespace as our services. Remember, we're going to install those into the monitoring namespace, so our secrets need to be there as well. So we'll hit enter, we'll create this secret, and Kubernetes says, hey, we created a secret. Now, if we wanted to make sure that Kubernetes has the right secret, we could do a kube-control get secret from the namespace monitoring, and then we're going to say, this is the name of the secret. We're going to output it to JSON path. And in JSON, we're saying use that property called data admin-user and then base64 decode it because they're base64 encoded in Kubernetes. So if you run that, we see our admin user. And if we run this command for the password, we can see our password there as well. So we're in a good state. So now we can install our kube-prometheus-stack. And that's as easy as running helm install -n monitoring for our namespace, Prometheus, the name of the deployment, and then the name of the repository that we're going to use. And then we're saying -f values.yaml. So that -f means file, and then we're providing a file to it, and it's that values YAML file that we just reviewed a little bit ago. So if we run this, it will start to install. And while that's going, let's pull up Lens and see what it's doing. If we look at Lens, we can see some things are starting to happen. We can see an overview. Things are getting pulled and installed. We can see we have some pending pods, some pending deployments, some pending daemon sets, some pending replica sets, some pending jobs, some pending everything. This is a good sign, so things are getting installed. And let's take a look at pods and see. So we see that Alert Manager is still coming up. Grafana is still coming up. It looks like it has 3 replicas. And Prometheus is still coming up. So these are all still coming up. You want to wait till these are fully installed. Here's the cool thing about Lens too. We can go and look at this specific deployment. We can see lots of stuff about it. We can see CPU, memory, file system. We can even see the pod logs right from here. So this pod is up and going. It's getting a 500, but it'll settle down here in a bit. And if we wanted to filter this by namespace, by monitoring, which I mentioned earlier, we can see all of our pods in this namespace now. So we have Alert Manager, Grafana, KubeState, node exporters for all of our nodes to scrape metrics, our Prometheus operator, and then our Prometheus deployment, or stateful set. So it looks like we're in a good state. Everything looks good to go, so let's check out Grafana. Now, as I mentioned earlier, typically you would want to install an ingress and expose this so that you can actually get to it. But Kubernetes has a really nice way to get to deployments or even individual pods without exposing anything at all. so you can do this without an ingress, and it's port forwarding with Kubernetes. So if I want to port forward to one of my services, say for instance, our Grafana service, I could go down to networking and go to services and click on Grafana. And right here, we'll see I can actually click on this and this will port forward to this service and I can get to it without even exposing it through an ingress. So if I click on this, it's actually going to open up a browser, port forwarded to my cluster, and I can get right in. So this isn't exposed anywhere in my cluster. It's all going through localhost and using port forwards to get to these services. So really awesome. And we can do that from a CLI too. I wanted to show you in Lens because that's really awesome if you don't want to run commands. So let's do it in the CLI too. So let's actually delete this port forwarding rule within Lens, remove, and that's in the networking section. All right, let's do it the terminal way. So the terminal way is going to be kube control port -forward and then your namespace -n monitoring is our namespace. And then Grafana, as you see, I did a tab completion. I enabled the Kubernetes plugin for ZSH, which will give me tab completion. It will go out, query Kubernetes, look for a pod, give me one. And here's our pod. And then I'll pick a port on the outside, which can be anything. I picked 52222. And then the port on the inside is 3000. So after we run this, it's now port forwarding this to my local machine. And if I go to localhost 52222, I can see my Grafana dashboard. So really awesome. So now let's enter our username and password. So I think it was admin user and then my super secret password, and I didn't get it right. It was so secret, I couldn't even figure it out. There we go. Got the password wrong. But the nice thing is it actually used our secret. So the cool thing that just happened was we used our secret from Kubernetes to sign in, and that secret's not exposed in our manifest at all. We referenced that secret in our manifest. So I figured it was worth teaching secrets just so we aren't setting our passwords in manifests or relying on the default password. But once we get into Grafana, this is typical Grafana stuff. Or is it? When we go into Grafana, we automatically have dashboards set up for a lot of the things we care about. For example, if we want to check Alert Manager, we already have data. So this is scraping the Alert Manager service and getting this data. If we want to check out etcd and see how etcd is doing, we have it right here. We can see that 3 etcd nodes are up, and we can see different metrics already in these beautiful charts. If we wanted to see how much compute resources our cluster is using, it's right here. So our CPU utilization is around 1%, almost 2%. So we've requested about 9%, and we've set a limit to around 2%. That probably needs to be adjusted. And we're right about 1%. So we're doing pretty good. How much memory we're using, these nodes have low memory. And so we're below the limit, which is good, which means our pods won't get evicted for the most part. But we don't have our requests set properly because we're over. So as it schedules pods, Kubernetes might not know where to put things, or it might try to put things where it doesn't have enough memory. Anyways, that's a pretty advanced topic. This looks pretty good. We have data. But you can see we have lots of data. So per namespace, I only have 3 namespaces right now, monitoring in MetaLB and Kube system, how much memory they're using, how much memory requests. And if we go back, we can actually see this per pod too. Now, if you land on this and you don't see any data, you probably need to change the namespace. Like I said, this is a clean cluster and I don't have anything deployed in default. So where did we deploy stuff? In monitoring. So as soon as we go into monitoring, we can see CPU utilization, memory utilization, and we can see all of our individual pods. So this is pretty cool. And as you deploy services, you'll be able to see all of this data for individual pods too. And since I don't have a ton of data here, I have one preheating in the oven at 350 degrees that's already been running for about 365 days. No, it's my home production cluster. So let's take a look at that. A lot more data there than this test cluster. Okay, so let's check out the dashboard on my home cluster. So if we check out core DNS, lots of activity there. So core DNS, a lot of queries for DNS within my cluster. And if we look at compute resources, oh, these charts look so good. You can see my compute resources per namespace. So networking, monitoring, Longhorn, Kube, GitLab, Flux, default, Cert Manager. I have a lot of namespaces. I try to keep them somewhat organized. But you can see I have a ton of data here, and this is so awesome to look at. You can see bandwidth per container or per namespace. And if we wanted to drill into individual pods, let's say, for instance, we wanted to look at my monitoring stack, we can see these individual pods and how much CPU utilization and how much compute resources they're using. So it's really easy to identify if something is going wrong or something's using a lot more than it should, like this one right here. Kind of a problem right here, but the memory request for this Prometheus, which I think is a replica set, is using 1,000% more memory than we set in its request. So I should probably increase the request so that it can be successfully scheduled somewhere with the appropriate amount of memory. But really cool, really cool. And if we want to see networking for my whole entire cluster, we can. And this is divided up, it looks by namespace. So who's transferring the most data out of everyone? It looks here like cattle system. Yeah, cattle system so far. It's transferring a lot of data, so cattle system is for rancher, but you can see cube systems up there, monitoring's up there, they're all doing things normally. I mean, this doesn't look out of the ordinary, 2 megabytes per second, that's not a lot. You can see bandwidth history over time, the min-max, average, the current, and we could see the average bandwidth if we want to, but I think there's some fancier gauges in here too. So if we look at networking at the namespace level per pod, if we look at the namespace monitoring, we can see how much overall bytes are received and transmitted. So a couple of gauges, but pretty cool, pretty cool. So you have charts already set up within Grafana for all kinds of metrics. Everything you see here. What happens if something goes wrong? And that's where Alert Manager comes into play. You can set up alerts based on metrics and based on thresholds to let you know when something's going wrong. Say for instance, my CPU utilization stayed higher than a certain threshold, say 80%, for more than 5 or 10 minutes, I can set up an alert to alert myself. And that's all done within Alert Manager, which if you want to know more about Alert Manager, we'll be covering that in a future video, so be sure you're subscribed to see how that turns out. So Grafana and Prometheus is pretty amazing. And it's pretty amazing that this Helm chart exists to fully configure your Kubernetes cluster with very little configuration. And for all of you out there, you can just use my configuration and save the hours of trying to figure this out for yourself. So I hope you learned something today. And remember, if you found anything in this video helpful, don't forget to like and subscribe. Thanks for watching. I know very little German. I think in like middle school, we took 4 languages in middle school, and I remember wie geht's heute, wie ist das Wetter, wie Glück, and liste listo. I think that means read the list, because I think our German teacher would tell us that all the time. Liste listo. And es ist windig. Es ist windig means it is windy. That's about the only German I remember from middle school German. That was a while ago too, so.